All right, should I get right into it?
Sure.
Okay, so my name's Artemio. I'm a first-year PhD student here, part-time in the program, and I'm going to be speaking to you about large language models today. As a full-time data scientist, I'm very passionate about this topic, and I think this is very relevant to everyone, not just those who are in data science. And so I hope to teach you a little bit about what goes on behind large language models, but also inspire you to utilize this in your everyday work. So the agenda for today are three main parts. I'll just be going through some concepts, the adoptions of LLMs, and predictions of what I think is going to happen with LLMs in the future. And I'll just go right into it. So what are large language models? I don't need to tell you what it is. There's so many different variations of definitions out there. But if you take a look at the top 7 companies in the S&P 500, I've amalgamated what they each say about what LLMs are. And so large language models are deep learning models and algorithms, statistical language models, natural language processing systems, and AI software as a service tools that are pre-trained on big data, consisting of billions of parameters to perform human-like language tasks by responding intelligently to human prompts. And so just taking a look at those icons, you can see some familiar brands over there that they've said, this is what they've said on their website, and I've just put it all together. So why are LLMs important? So they have the ability to generate real human language that positively impacts human productivity at work. They can facilitate communication between humans and machines. They enable task routine automation and personalization of recommendations and experiences. Who here uses an iPhone? 1, 2, 3. Yep. So yeah, I mean, you're already using LLMs within your devices, right? If you look at the bottom left, OpenAI has quoted, OpenAI and Apple announced partnerships to integrate ChatGPT into Apple experiences. This is what Microsoft says as well. Long-term partnership with OpenAI through a multi-year, multi-billion-dollar investment to accelerate AI breakthroughs to ensure these benefits are broadly shared with the world. And so if anybody here uses any Microsoft tools, for example, Microsoft Word, there's already a lot of LLM work happening behind the scenes there. And so how are LLMs currently used? These are some examples from the industry. But some interesting things to point out here. For example, in finance, financial risk management, if you scroll down to education, it's using question generation, essay grading, and feedback. I know all of you are sitting here probably going into class. Is this something I can ChatGPT? Can I ask a question and it'll provide me answers? I know a lot of profs have a lot of pet peeves that are going around right now when using ChatGPT, but it is widely used in education. As researchers, learning researchers, we might be using ChatGPT or LLMs in our line of work as well. And then some other interesting things that are happening in industry. Legal services, legal research, document processing and analysis, contract generation. And so if there's any place, anywhere in the world, anything at work or in your own line of work where you can imagine textual data being automated for information processing, or something to speed up your tasks, LLMs, there's a chance that it might be already being used there. For this slide, I'm just going to go through a quick overview of the history of evolution of LLMs. In particular, as a data scientist, I started my career back in 2014. And a lot of the stuff that you see here is quite fundamental. And it actually has been asked of me in interviews. These are very conceptual things that led up to what we see today in LLMs. And so I'm going to start at the very beginning in the 60s. Anything that's highlighted in blue are algorithms, very important if you want to know, if you intend to go into data science as in a career. Anything in red, these are real world consequences and applications of what you might see with LLMs. And so in the 60s and the 80s, it was really about preliminary language with machines. Can I input a simple question in a machine and can it spit back to me a simple one-word answer, a simple phrase? That was really what we saw with ELIZA, Sherdloo, Excalibur. But what was really important at this time in terms of innovation was the neural network. And so recurrent neural networks, these were mathematical representations representing biological neurons. And an important innovation at this time was the backpropagation algorithm. And so you can imagine with a set of mathematical equations, you're feeding data into it, and as these neurons are processing this data, it's calculating and optimizing what's the right answer. But if it assesses any errors along the way, it's going to feed those errors back into the system so that it can continue optimizing until there's a better answer at the end. Into the 90s, into the 2010s, we then move into the LSTM GRU. Sorry, I put LSTM twice here, but it should be transformers. The LSTM, which is the long short-term memory, it was created in the 90s, and the innovation here was larger textual input that captured context by something they called the input, output, and forget gate. And what this means is, think about when you try to remember a piece of text for yourself. If I read you a sentence, you'll probably remember it. If I read you a paragraph, you'll probably remember bits and pieces of it. But if I read you an essay, you'd probably remember the most recent thing. You'd probably forget a lot of what I had told you in the first few paragraphs. And so that's what the LSTM algorithm sort of worked through, is once you have an input, it outputs text, but then it forgets context that is not necessarily relevant to what you want to remember. The gated recurrent unit, right, it superseded the LSTM. And what happened here is that it was a more efficient architecture, and it eliminated a lot of the convergence issues that LSTM had in its algorithm. And by this time, in the 2010s, NLP and real-time predictions became very possible, and this being utilized within systems. Real-time predictions being forecasting, for example, time series data. In 2017, transformers sort of became a very pivotal moment in AI, large language models history, with the innovation of self-attention mechanisms. And so there's a very popular paper by Google. It's called Attention is All You Need. This was the most hyped up paper in the industry as it relates to machine learning and AI. I highly suggest you go read it because everyone talks about it. It was a very pivotal moment for Google, especially. And what this mechanism did was it assigned numerical weights to different words in the sentence. And so if I read you a sentence, you would pick up on certain aspects of that sentence that was important to you because there was a higher numerical weight assigned to it. With the advent of transformers, text summarization, sentiment analysis became very prevalent with this innovation. And this is what sort of now spearheaded everything into the future. When we talk about 2018 to the present day, if you take a look at the top right, now we get into BERT and GPT. BERT was the bidirectional encoder representation from transformers. It was an innovation by Google, once again. And the innovation here is something they called masking. So again, if I gave you a sentence, I would randomly mask or hide one of the words in that sentence, and then the algorithm would predict what that word would be based on each word in that sentence. And it did this reading from left to right, and then it would do it again, reading from right to left. And so this became very, very widely applicable to many, many tasks because of the algorithm. It gave rise to named entity recognition. And one of the most important things in machine learning when it comes to supervised learning is fine-tuning. So with BERT, it gave everyone the ability to have different domains, apply this to different domains. When you have a set of textual data in legal, in hospitality and tourism, in education, you can upload your data into BERT and then train it, retrain it, and then it could start spitting out answers to you that were very specific to your domain. And this is where it became widely applicable across many industries. But in response to Google's innovation, OpenAI came around with GPT. GPT's answer to BERT was a unidirectional version of what Google had created. But in their case, GPT created more coherent sentence structures, and they were able to process larger bodies of text. Moving into GPT-2 and GPT-3, what I wanted to highlight here was, the applications of LLMs are huge, right? OpenAI added 45 million websites, 8 million documents, and they were able to produce a machine that could produce descriptions of real-world contexts. So you can think news, entertainment, fictional stories. And then they went even further than that. They added standardized testing to their knowledge, and everything up to September 2021. And I don't know if you remember a few years back with all of those headlines that were hyping up ChatGPT, saying, oh my gosh, it could pass all of these standardized tests. I was sitting there being, well, it was trained on that data. Of course, it's going to do very well on all these tests. But I think it was used to create sort of this hype and sort of fear-mongering about LLMs. And so I think it's important to know that at the end of the day, these are AI systems that are trained on large bodies of data, and they don't just come up with this on their own unless they hallucinate. And I'll go about that. I'll talk about that later. Another important algorithm that OpenAI came up with was the idea of zero-shot and one-shot learning. You probably already inherently do this when you're using ChatGPT. So for example, if I want an answer to a problem, can you calculate or give me code for this particular problem? It'll spit back lines of code. Let's say it's in Python. That's zero-shot learning. In one-shot learning, I provide an example of what I want, and then it'll give me the answer. So for example, if I say, I want line of code to produce this problem, but I want it to be in SQL. I don't want it in Python. And so by providing that example, by providing that cue of what I want, then GPT knows to focus its output on SQL, for example. And so zero-shot learning, one-shot learning is just the difference between do I provide GPT an example or not. Now if I move really into the present day, we're talking like literally seconds as we're currently talking about this. ChatGPT really took the world by storm. This was back in 2022. I remember I was sitting at home and it was COVID, pandemic, staying at home, but ChatGPT made it into the headlines about how amazingly it can produce human-like output. And what really stood them apart was their innovation on reinforcement learning. And this is such a huge topic now, especially if you're going into data science, machine learning, engineering. This is a topic that everyone's asking about, that everyone expects you to know, specifically for large language models. And I'll show you in the next slide what reinforcement learning is, but this is a very important algorithm that really set OpenAI apart from its competitors. And by competitors, if we compare them to Google and Meta, they start to enter the race of large language models as well. Google, their creation of PaLM, pathway language models, and Gemini, and then Meta with their open source LLM called Llama. So that was quite a lot of algorithms and topics sent to you, but I think a very important tenet of large language models is the idea of reinforcement learning. And so if you take a look at the top right, if you've everyone's here is familiar with ChatGPT's platform, correct? So when you type out a question or an input and it returns to you an output, sometimes you'll notice a little check mark or a little thumbs up at the bottom. And that's OpenAI's way of saying, okay, did I provide you the correct output? If I did, click check mark. If not, thumbs down. What they're doing in their platform is then using that as a signal in their own training systems to better refine and better train the model. And so you can think of each individual sitting in this room using GPT as contributing to the vast knowledge of what's happening inside of ChatGPT. And then as you can see here, with your feedback, it feeds into better models. The more users they have, a more well-rounded amount of information that enters and trains into the GPT.
So is that in real time?
This is not done in real time. It's done in batches. And so they have, I don't know the timeliness bit. And actually, we do see that nowadays, right? Like the time between GPT-4 and GPT-4o and 4 mini, it was like a couple of months, right? They're very quick on that, but yeah, exactly, yeah. Any other questions with respect to the slide? Okay. And so I'm going to start talking about some alternatives. Alternatives in the sense that there are over 50 different large language models out there today, some of which are from the major companies that I mentioned before. But when you look at alternatives, here are some ideas of what you can be looking for from an organizational point of view, right? At the end of the day, it comes to cost. And so what are some of the things that you might worry about, right? What's the quality of the output, your output speed, latency, how quickly can you communicate with an API? What's the price per tokens and the context window? How large of a document can your LLM process? And so here are some of the top-ranked LLMs that you'll find in each of these categories. And these are very real. These are very quantifiable ways of choosing which LLM you might want to use. I did provide the source there if you're interested. But yeah, there's a whole table of many different LLMs. One thing I do want to point out, though, is that if you notice Meta's Llama up there in the output speed, and then you compare it to everything else, it just goes to show that open source tools and private tools are comparable, can be comparable. And so you're free to actually go online and use Meta's Llama today as a full-fledged LLM. And then now I'll be talking about the market share and penetration. And so just quickly looking over at the left map over there, there's a prediction that 31 to 32% of North America's revenue share is made up of purely AI and large language models. And over on the right, this is sort of corroborated in another way from a different market research team. They say that 33% of the revenue share is going to be dedicated to large language models. And this is definitely coming up by small startups, entrepreneurs, technology companies. In terms of the share, you can take a look at this pie chart again based off this research team. $4.3 billion just in 2023 was dedicated to AI. And more specifically, in the large language model market, you can see that about a quarter of that comes from retail and e-commerce. So you can think customer experience, customer service, chatbots around that place. You can see finance, healthcare. So a lot of these industries that utilize text in one regard, they're already utilizing this and putting billions of dollars into their industry and processes. Next, I'll talk about demographic adoption. So here, I just showed an example. KPMG surveyed 4,500 Canadians, and they found that 20% of individuals use AI today. An interesting metric here is that individuals save about 3 hours of productivity when they're utilizing large language models. And then in terms of tasks, mainly used for research, generating ideas. And so you can start to think about, how am I using large language models? It's about content generation. It's about coming up with ideas, answers to questions very immediately at the tip of your fingertips. What does the literature say about demographic adoption? There was a study done on US users by Draxler and his team, and they found that younger individuals are more likely to utilize large language models. They found that there is a disproportion of proficiency between males and females. So this study, they actually did take 50% males, 50% females through randomized stratified sampling, and found that males were more proficient in utilizing LLMs. And then they found that about 30% of them used it at work at school for searching math problems, data analysis, and writing emails. And then there's further research to support the fact that younger individuals utilize LLMs more. In terms of industry and organization adoption, I've mentioned these before: finance, healthcare, education, and technology. But one thing I wanted to focus on really was the regulatory environments, right? LLMs are being used differently across industries based on different things. For example, healthcare and government, legal compliance and accuracy of records; finance, mitigation of financial and corporate risks; entertainment, content generation and copyright challenges, right? You might imagine entertainment maybe being against using LLMs because of all of these copyright issues. And actually in the news, there's a lot of talk about how can we protect artists, writers, because of everything that they're writing and producing. And all of this data is being used by LLMs. And then in addition, R&D opportunities. And so there's a lot of ideas out there that are currently being worked on, such as chatbot coaching and tracking through the health and fitness industry, urban planning, satellite imaging, and traffic management. How can we take satellite images, translate that to text, and then use that to inform decision makers? And then disaster response, radiation and floods. Are we able to describe events that are happening in real time in order to make decisions, quick decisions to respond? And here's some quotes that I found. What's really interesting is that 6.1% of businesses in Canada utilize AI. And so this is sort of going to feed into some of my predictions later on. But I thought that was pretty fascinating. AI is widespread and it's happening and being developed very quickly. But very, very few businesses in Canada are adopting it. Bain & Company said 75% of manufacturing companies globally have not yet adopted AI technologies, but are planning to consider or start in 2024. We're near the end of 2024. I don't know where that stands today, probably much less than that. And then McKinsey & Company say 79% of survey respondents have exposure to AI, but only 22% of them actually utilize it in their own work. And so you can see that there's a lot of AI technologies, specifically large language models, that are being utilized, a lot of investment at work. But there's still time needed to actually try to find that right fit with everyone's workflow. The final section of my presentation is predictions. And predictions I have are motivated by a call to protect societies of the future. Right? So here's some information that we know about large language models. GPT-3, very proficient at human language, but it leaves a lot of room for misuse, misinformation, fraud, gender biases, and racial biases, which may perpetuate racism and discrimination. Pathway language models by Google. It's subject to demographic bias and language toxicity. Chowdhury and team, they're the head engineers at Google, and they specifically noticed this in their white paper saying, we have this amazing technology, but we actually acknowledge all of its limitations or negative consequences. Meta's Llama, they displayed observable bias, toxicity, and misinformation, but additionally a large carbon footprint. Right? You can imagine all this big data needs to be stored somewhere, generating a lot of electricity usage, large carbon footprint. In addition, hallucinations, data biases, and knowledge cutoffs may perpetuate misinformation and deceptive rhetoric. ChatGPT exhibited biases towards gender and jobs. Physical demanding jobs were usually performed by men, healthcare jobs performed by women. Meta's Llama associated higher salaries with men. And so you can know there's a lot of gender biases that are happening within LLMs. And how the authors did this was asking specific questions related to specific jobs and industries and see what the output would be. And finally, there are biases against populations of low economic status on topics including attractiveness, morality, and intelligence. The authors of this paper, Rohan and team, they found through studying African countries that when they asked specifically about these countries about attractiveness, morality, and intelligence, they were lower compared to the Western world. So what is currently being done to help society, right? Gemini, created by Google, they're creating mechanisms to prevent hate speech, harmful language, and audio, dangerous video content. To what extent they're doing this, I have no